Hey, what's going on, guys? Games here. A quick update on Wukong UCI chess engine development progress in this video. So, I've been testing Wukong versus TSCP again and again and again, and I've noticed a very strange behavior. Like, the first from 5 moves, maybe 5-6 moves, Wukong is doing much better in terms of performance, but then it starts getting very slow, just slow as hell. And I was just thinking that that's the matter of the exponential growth of the captures in the middle game positions, or things like that. But eventually, it turned out to be much. It was a trivial thing that was actually causing that sort of behavior. So I was a little bit depressed on this sort of behavior of Wukong, and I decided to refresh my memory regarding the search functions and how they are implemented within the TSCP actually. So I just opened the search.c file from the TSCP source code and started diving into this, and I was like seeing what's happening here. So okay, so you just tried to take the book move, so some code to manage the time, which is quite pretty nicely, the routines to get the time taken by the search to calculate a move, things like that. And then suddenly I've seen these two lines of code, and I thought, like, oh my god, I just forgot to reset my history array, killer moves, and the principal variation table. Like, how could I miss that? And obviously I've stopped researching code further on, and immediately I've fixed this bug. So I did add this 3 lines of code in order to reset the pivot table array, which is and all these arrays are 2-dimensional arrays, but still we can reset them within in one line using this standard cmemset command. And even a better idea, even a better optimization would be probably to replace this size off by the constant integers to speed up an execution a little bit, so the size of function is not getting called millions of times. But even with this sort of an implementation, I can already see, I can already show you what a huge difference in the performance we have here. So before we start, let me just open the arena, and also, yeah, obviously I need to compile the code, so I will compile for release to make it faster. So the problem is that the history moves, killer moves, and principal variation moves were obviously they were kind of overwritten the previous results, but there were lots of garbage results from the previous searches, and that did not increase the move ordering, but instead it did decrease the move ordering, and it did increase the number of traverse nodes, which were absolutely unnecessary. So if we just let's just open arena, and now I'll demonstrate how Wukong plays itself at the depth of 6 at 6 ply depth here. So let's adjust the engine to playing 6 ply depth, and just let's play itself versus itself. And you see, like, it starts quite pretty nicely, yeah, and for some reason, I don't know why did he stop printing these notes, but as far as, yeah, now it prints. But as far as it goes further on, it starts playing slower and slower and slower and slower. That's because the principal variation table and the history moves table and the killer move tables are getting polluted with unnecessary data from previous searches and not getting cleared. Even though the position is still quite pretty reasonable and the game is just pretty fine, still it's getting slower and slower, and eventually it starts being slow as hell. So I will now just show you how the performance is gonna boost after I actually do this absolutely essential step of clearing the search information every time we make a new search there. So let's close the arena to recompile and restart, to recompile the engine and restart it later on. So I just now want to uncommand my cleanups here, save, and by the way, how I did realize this, I just tried to search the same position, the initial position at the same depth, several times, and every next time it did actually do the same job with more and more nodes every time, because of this because of the search info wasn't really cleared. Okay, so let's make it for release again to make it faster, and you'll see how what a different game and what a different speed is gonna be now. So at this point, okay, so just while it would be playing, I'll describe a couple more insights regarding the development process. Okay, so let's go for this again and have a look how faster it plays, and the depth is still kind of this 6. Well, I understand that it's not really that fast, but it's really kind of faster compared how it was before. So I don't know, maybe it's not really seen by the eyes, but it's really faster, really. Well, I don't really remember how many time it took to reach this position, but I guess slightly more than 15 seconds, right? So I hope you can see that it really plays faster now. So I've tested this version against TSCP again, and what an interesting stuff I realized. Well, actually, instead of talking about this, I would rather show you this, guys. So let me just start a new game, and let's go to, well, the only thing, I just need to recompile my blitz search to fix depth of back to 6, because it forfeits some time in the depth of 7, even though it gets the better position first time within this development process, but still, just to show you the speed. So if you've been watching some previous videos on Wukong playing versus TSCP, you probably remember that I couldn't even make them play Blitz, because on Blitz TSCP was first was kind of 2 times faster than Wukong, and even more when it came to the very end of the game. So okay, now let me restart this again. So what I want to oh my god, so what I want to say here is, at this moment, even though the position they're playing are still the same, and due to the poor evaluation function, Wukong still loses at loses versus TSCP, but now it takes less time than TSCP, believe it or not. I just want to demonstrate you this stuff. So levels adjust, and let's play 3-minute blitz. Okay, and let's invite the TSCP to this game. Okay, hold on a sec, it didn't yeah, like this. Okay, and let's make a new game again. So yeah, now both engines are being loaded. So not regarding the class of the game, but I just want to show you. So TSCP is playing white now, so let's watch this from the Wukong's perspective. But if we have a look at this time spent by TSCP versus the time spent by Wukong, eventually, well, now they are about equal, but eventually TSCP would start losing on time, and this is really interesting. So you see, like, Wukong making moves much faster. So, well, maybe not much faster, but when we go a bit further into a game, even though, again, like, unfortunately he still loses this game, but further on in the game it would have more time here. So it's already 15 seconds up. So let's have a look at the nodes. So before I saw like the nodes for Wukong were better just in the first couple of moves, but then obviously this was a complete disaster. Well, now, well, I'm not sure why. Yeah, now TSCP 2 millions. Yeah, okay. So okay, and TSCP. Well, it's not always better, but. But nevertheless, if you have a look at the time, you already see that Wukong is actually winning on time. Even though the position is kind of bad, but he kind of plays a little bit faster, which is already a big victory for me personally. So, yeah. So almost 30 seconds up at this point of the game. The move's number 16. And the nodes, well, this is a little bit strange. It seems like in most cases TSCP does less nodes than Wukong, but for some reason it takes him longer. Maybe he's not calculating the quiescence nodes. I'm not sure. That's actually we can easily answer this question if we have a look at the source code. So let's have a look at the source code. It has to be something like nodes plus plus, and it's not here even. Okay. Yeah, here are the nodes. Okay, so he adds the nodes in the Nigamax search. Okay. And he adds the nodes in the questions. Yeah, so sorry TSCP. I just thought he didn't increment the nodes within the questions, but he does actually, which is good of him, obviously. So not really clear why the nodes values for Wukong are bigger in most cases. Well, actually we can compare the positions because like the position that the one position is really different from another, and in order to compare this node values, we really need to compare engines evaluating exactly the same position, not the opposite position, obviously. So I guess the proper way of defining of kind of how to say that, the efficiency of traversing nodes, of the number of traverse nodes is probably to be done is to be judged by the timing, because you see like Wukong had spent less time compared to TSCP. And what is even more strange again is that I don't really remember this position. So either I've changed something and already don't remember that, or maybe just TSCP is playing just slightly bit different game. Well, he's definitely better, so he has a protected passed pawn, and these two passed pawns should win the game, obviously, and the time for him would be enough, absolutely for sure. So Wukong would have to give up his bishop. Okay, yeah, and now the pawn is queening. Nothing to stop the pawn. Yeah, so yeah, it seems like it's the exact position I've seen basically. So yeah, now Wukong is gonna get mated, unfortunately. But if you have a look at the time, still he's kind of now at this moment he's eventually he's 20 seconds, almost 20 seconds better, or even slightly more. It's almost 30 seconds better, right? So this is the magic behind clearing the search information every time you're making your search, basically. So such a nasty bug did a real pain to Wukong's performance, and it was really slow as hell because the move ordering was completely smashed by the uncleared previous previous results from the previous searches, which is a really bad thing. So, but from now on, we have a slightly better performance, which is really great already. And probably this is happening because Wukong is using killer moves. Well, it doesn't seem that the TSCP is actually using the killer moves. So if we just have a look at the beta cutoff of TSCP within his Ninja Max search, not within the questions, but here within the Ninja Max search. So yeah, this one. So okay, so here's the alpha increases, so stores the PV. By the way, the logic of retrieving the principal variation I've taken from TSCP a long time ago, and now I'm still kind of using this because this is really easy and straightforward of getting the principal variation out of the search. Okay, and where is the beta cutoff? I can't see the beta cutoff. Yeah, this is the beta cutoff. Yeah, he plays this within this alpha increasing part, which is generally normal. Yeah, so he just keeps track of the history moves to order the quiet moves, but he doesn't really take care of killer moves, which Wukong does. So he just returns the beta. It just does nothing on the beta cutoff. That's kind of it. And if we have a look at the Wukong's implementation, so let's search for the killer moves, and yeah, here we got the array to store the killer moves, and here we order the killer moves, the first and the second killer, which allows you to narrow the search tree quite pretty nicely. And yeah, and here is the beta cutoff part within the Wukong, and here what we do, we just updating the two killers, so the first killer becomes the current move, and the second killer becomes the first killer, the first killer of the previous iteration, so something like that. Well, okay guys, so this is it for this video. I wish you to clear your search information in your chess engines, because otherwise it would be a completely disaster. So don't forget to clear your search information, your data structures responsible for storing some historical search values there. I guess this is it from my side. I will work on improving Wukong slightly bit more, and then we'll have a blitz match versus TSCP. And again, like what I was already mentioning, so the challenge is to leave the evaluation function just as is and try to make Wukong win due to searching to the deeper depth. So I want to if Wukong plays with a depth of 7, I didn't yet test this because on Blitz it just forfeits on time, and I didn't yet test this on the fixed depth. Actually, I can't. Actually, on the fixed depth, they both would be playing with the same depth. But if we have a Blitz game, we have that Wukong can be playing 7-play depth, while TSCP would be playing only 6-play depth according to his implementation. And at this moment, again, like as I was already mentioning, Wukong is much slower than TSCP when it plays 7-play depth. It's about the same speed how it was playing when it was 6-play depth, but without clearing the search every next iteration. But the position is that where he forfeited on time. Both engines, both TSCP and Wukong, considered Wukong's position to be slightly better, assuming that he was playing black. So I will try to improve the search even more. I'm not really yet that sure how exactly I'm supposed to be doing this. Maybe I will add some null move prodding or things like that. So, and as far as the performance at the and as far as the search with a fixed depth of 7, would it be as fast as the TSCP search at the depth of 6? I will then try to make them play a couple of blitz games, and if there would be more than a couple of blitz games with some sort of variety, I will be happy to watch them as well. And obviously, I will share this. I will make a video on this and share the results and the performance and all the stuff, all the show with you guys. So this is it from my side. I hope you have enjoyed this video. Maybe probably learned something interesting out of it. Don't forget to clear your search info. So this is it from my side. Until the next time, and take care.